Shanklin, on the Isle of Wight, the 12th of August, 1944. Salt air, the smell of hot tar and diesel, and a low mechanical hum coming from a cluster of requisitioned seafront bungalows that, to any German reconnaissance flight passing overhead, looked like nothing more than an ordinary English seaside town. Out in the swell, half submerged, a steel drum the size of a small building turns slowly in the current, unspooling something into the water that has no business being there. This is more than 2 months after the largest seaborne invasion in human history has already stormed the beaches of Normandy. The tanks are already deep inland. The trucks are already burning fuel by the hundreds of thousands of gallons a day. And yet the thing that is supposed to be feeding that machine is only now, for the first time, beginning to work. Here is the part that doesn't add up. Planners had spent 2 years and enormous secrecy building a system specifically so that no vulnerable oil tanker would ever have to cross these contested waters. But the invasion had already been running for 10 weeks without it. Armies had already broken out of the Normandy hedgerows, already pushed toward Paris, already outrun the very supply line built to sustain them. And they had done it anyway, using the tankers and the beach pipelines this project was designed to make unnecessary. So why build it at all? Why keep building it, testing it, laying it across a minefield of a sea, if the invasion could apparently succeed without it? This is not really a story about a pipe on the floor of the English Channel. It's a story about what happens when the thing engineers spend years perfecting turns out to matter for reasons nobody quite predicted. To understand why anyone thought a pipeline under the sea was worth the risk, you have to go back to a much older and much bloodier lesson about fuel. Modern armies do not run on courage or steel alone. By the early 1940s, British planners estimated that something like 2/3 of everything a mechanized force needed to keep moving was, in one form or another, petroleum. Not just for the vehicles themselves, but for the aircraft flying cover above them, the generators running their radios, the landing craft ferrying the next wave ashore. Take the fuel away, and the most powerful army in the world stops, in place, within days. The obvious way to move that much fuel across a body of water is by tanker, and in 1942, tankers were exactly the problem. German submarines were sinking Allied shipping across the Atlantic at a rate that horrified planners in London and Washington alike, and the English Channel, narrow as it was, offered no real safety. A tanker sitting still off an invasion beach, slowly pumping fuel ashore, was also a tanker sitting still in range of shore batteries, aircraft, and torpedoes. Lose a handful of them on the wrong afternoon, and an invasion could be strangled in its first week, not through defeat in battle, but through an empty fuel line. There was a second problem, quieter, but just as serious. Every tanker sent across the channel to feed the invasion was a tanker not available somewhere else, and by 1942, the war in the Pacific was placing its own growing demands on the world's tanker fleet. Britain could not simply build its way out of the shortage. It needed a way to move fuel that did not depend on ships at all. That is the idea that reportedly took shape in the mind of Lord Louis Mountbatten, then head of Britain's Combined Operations Command, sometime around the spring of 1942. Mountbatten took the problem to Geoffrey Lloyd, the government minister responsible for wartime petroleum supply, and asked him a question that must have sounded faintly absurd at the time. Could you run a pipeline across the floor of the English Channel? Nobody had ever laid a pipe of that scale across open, tidal, current-torn seabed before. The engineers Lloyd consulted initially considered the idea close to impossible. Hold on to that word, impossible, because it comes back later in a very different context. For more incredible true stories from World War II, carefully researched and brought to life, subscribe to the channel and never miss a new documentary. The man who found a workable answer was Arthur Hartley, chief engineer of the Anglo-Iranian Oil Company, brought in as a consultant to the Petroleum Warfare Department. Hartley's insight was almost sideways in its logic. Britain already had decades of experience laying something long, flexible, and continuous across the floor of the sea: submarine telegraph cable. If a cable could carry a signal across an ocean bed, reasoned Hartley, then a modified version of that same cable technology, hollowed out and reinforced, might be made to carry fuel instead of electrical current. Out of that idea came 2 competing designs.
And this is where the project's real technical ambition shows itself. One design, built around Hartley's cable concept, became known by the acronym HAIS for Hartley, Anglo-Iranian, and Siemens, the cable manufacturer whose telegraph expertise was repurposed for the job. It was flexible, which made it far easier to handle and lay from a moving ship, but it relied on a lead lining, and lead was a metal Britain could not easily spare in the middle of a total war. The second design, called Hamel, after the engineers who developed it, was a lighter steel pipe, cheaper and less dependent on scarce materials, but far less forgiving to bend and reel. Both designs had to be tested somewhere Germany would not be watching. In May of 1942, engineers ran early trials on the River Medway. The following month, they tried again in the Firth of Clyde, off the coast of Scotland. And at the end of that year, over 5 days in December, a converted vessel laid a genuine sea trial line, roughly 50 kilometers long, from Swansea across the Bristol Channel to Ilfracombe. It worked. The proof of concept was real, but it was also, by the standards of what would eventually be needed, a small and gentle rehearsal for what the channel itself would demand. Because here is the number worth holding on to for later. The actual crossing to France would need to run some 70 miles, through some of the strongest tidal currents and busiest, most heavily mined waters in Europe, with the constant threat of enemy interference the whole way across. Before we get into how they actually managed to lay that much pipe across open water without a single German patrol noticing, it's worth pausing to say, if a story like this is the kind of thing you enjoy, stick around and consider following along, because the next part is where the engineering gets genuinely strange. You cannot simply feed 30 miles of pipe off the back of a ship the way you might unreel a garden hose. The pipe had to be stored, transported, and laid in a continuous, unbroken run, at sea, under tow, without snapping under its own weight or twisting itself into a knot on the seabed. The answer the engineers arrived at was a piece of equipment almost absurd enough to have come from a comic strip. An enormous floating steel drum, built to hold the pipe coiled around a central axle like thread on a spool, designed to be towed across the channel while rotating in the water and unreeling itself as it went. Someone, with the particular dry wit of wartime engineers, named the device the conundrum, and the name stuck. These were not small pieces of equipment. Each drum was around 30 feet across, and when fully wound with pipe, represented an enormous concentration of steel and cargo bobbing in open water, under tow by ordinary tugs, in full view of anyone who happened to be looking in the wrong direction at the wrong time. 6 of these drums were reportedly built and ready by the summer of 1943. Nearly a year before the invasion they were meant to support even took place. Now, here is the misconception worth correcting directly, because it's the one that trips up almost everyone who first hears this story. Most people who know anything about Pluto assume it went into action on D-Day itself, or within days of it, feeding fuel to the invading armies from the very start of the Normandy campaign. It didn't. The codenamed line from the Isle of Wight to Cherbourg, known as Bambi, did not become genuinely operational until the 12th of August 1944, more than 2 months after the landings. A working cross-channel line from Cherbourg to Sandown wasn't actually tested, commissioned, and brought fully online until the 22nd of September that year. And even then, it was only delivering something in the range of 56,000 imperial gallons a day, a fraction of what an advancing army group actually consumed. A second line, using the sturdier Hamel pipe, came into service about a week later, and then, within days of both finally working, both lines failed. One from what investigators believed was a faulty coupling, the other because the pipe had been laid across a sharp ridge on the seabed and simply cracked under the strain. So, the picture the popular version of this story likes to paint, of a secret pipeline quietly and heroically fueling the liberation of France from the moment the first soldier hit the sand, simply is not what happened. For most of the Normandy campaign, the fuel that kept the tanks moving came the old-fashioned way, by tanker into the newly captured harbor facilities, then overland by truck, and by a temporary network of land pipelines. Pluto, in its first incarnation, was late, underpowered, and unreliable exactly when it was needed most. So why does this project still matter enough that we're talking about it today? Because of what happened next. This is the part that deserves real credit, and where the popular telling of Pluto as a slow-starting engineering curiosity actually undersells what it eventually became. Once the Dover Strait lines were established, fuel began flowing in genuinely useful volumes, feeding the advancing armies as they moved deeper into Belgium and the Netherlands. Taken across the whole period from August 1944 to the end of the war in Europe in May 1945, the pipelines are estimated to have delivered somewhere in the region of 172 million imperial gallons of fuel to the continent, a genuinely enormous figure, and one that stands as one of the more remarkable feats of underwater engineering of the entire war. For more incredible true stories from World War II, carefully researched and brought to life, subscribe to the channel and never miss a new documentary. But here is the turn, and it's an important one because it complicates the version of this story that flatters the engineers the most. For all that impressive total, historians who have looked closely at the overall fuel supply for the Northwest European campaign have concluded that Pluto, across its entire operational life, accounted for something on the order of only about 8% of all the fuel actually delivered to Allied forces. The overwhelming majority still came the way planners had originally hoped to avoid, by tanker, by fuel canister, and by aircraft. The pipeline that had been conceived specifically to reduce Britain's dependence on vulnerable tanker traffic never actually replaced that tanker traffic. It supplemented it in a modest, useful, but far from decisive way. That is not a failure exactly, but it is a genuine correction to the record, and it's worth sitting with rather than glossing over. The engineers who built Pluto solved an extraordinary technical problem. What they didn't solve, and arguably couldn't have solved given the pace of the actual ground campaign, was the deeper logistical bottleneck of feeding an army that was advancing faster than almost anyone had planned for. The armies that broke out of Normandy moved with a speed that outran every fuel plan drawn up for them, Pluto included. In that sense, even the most careful, best-resourced planning in Whitehall got outpaced by events on the ground, and admitting that is more honest than pretending the pipeline single-handedly kept the liberation of Europe moving. Go back for a moment to that beach terminal at Shanklin on the 12th of August, 1944. Picture the men actually running the pumping station there, the engineers and technicians who had spent 2 years designing, testing, and retesting a piece of equipment most of official London had once called impossible. We don't know most of their names. The engineering records that survive tend to remember Hartley and Lloyd and Mountbatten, the men who conceived and championed the project at the top. But the people who actually stood on that shingle beach watching a conundrum spin out its pipe into the swell, who tightened the couplings that would later fail under strain, who watched the pressure gauges for the first sign of trouble, mostly went unrecorded. A young engineer, perhaps, transferred from a peacetime oil company into a uniform and a secrecy classification, standing on a beach that had been quietly turned into one of the most sensitive industrial sites in wartime Britain, without ever being able to tell his own family what he was actually doing there. That is who this story ultimately belongs to. Not to the anomaly of a pipeline running late, and not even really to the impressive final total of fuel it delivered, but to the ordinary technical patience of people solving a problem nobody had solved before, under enormous pressure, in near total secrecy, without much guarantee that any of it would work in time to matter. So to return to where we started, why keep building something that the invasion had already proven it could succeed without? Because success in a war like this one was never measured by a single supply line. It was measured by margins, by how much slack you built into a system that could not afford to fail even once. Pluto didn't win the campaign in Northwest Europe by itself, and it didn't need to. It existed to make sure that if the tankers and the temporary harbors ever did fail, there was something else already running under the sea, quietly, that the enemy didn't even know was there. This was never really a story about a pipe. It was a story about the unglamorous, invisible work of making absolutely sure that an army never runs dry, even when nobody is watching, and even when the plan doesn't unfold the way anyone expected. A war can be won on courage. It is only ever sustained on fuel. Next time, we'll stay on the English coastline a little longer and look at another wartime engineering secret hiding in plain sight.